There we go. All right, let me tweet out and then we'll get started. Let's see what we got. Sick. All right, we're live, boys. Let's see. I've been kind of scrolling through Hacker News. I think one of the interesting things here. Hold up. Real estate investors bought a record 18% of U.S. homes that sold in the third quarter. Holy shit. My question is whether or not those were like under contract beforehand or not. That's my question. Because if you sign the contract in like let's say 2016, and then sold in and executed in 2020, 2021, then that's a different story. So let's actually see. Investors purchased $64 billion worth of homes. Yeah. Investors have the largest market share in Atlanta, Phoenix, Charlotte, Jackson, and Miami. Okay. So it's across the nation, sure. We define an investor as any institution or business that purchases residential real estate. Okay. Investors bought 90,000 homes, up 10.1%. Blah, blah, blah. Okay, cool. In dollar terms, investors have put a record $63 billion, up from a revised estimate of 58 and 35 billion a year earlier. Okay, that's just kind of shown in the graph. More than 3/4 of all investor homes were purchased with all cash. Holy shit. Increased home prices fueled by an intense housing shortage have created opportunities for investors to reap big profits. Okay, rent 10.7, yeah. Rents rose 10.7 year over year in September, sure. While the median home price sale increased 13.9%. With cash-rich investors, many individuals found it tough to compete. Bidding wars on decline and home growth. We may see investors slow their roll. All right. It's hard for me to say. I think I'm trying to look up all of this, but to me, if I had to make a comment right now, I feel like most of the activity would be concentrated in areas where housing permits have been substantially rejected. So I'm kind of noticing here that very few of, like, no one's buying single family homes and multifamily housing units or condos. Yeah, it's a record low. Condos just like are not moving at all, but everyone's buying real estate itself. And I guess that kind of makes sense because everyone wants a house. No one wants like a condo, regardless. So if you own a condo, this shit means you move sideways. So my question is, why? I guess they're just looking for more space because condos are usually associated with the city, which kind of makes sense. Yeah. Demand for condos will rebound. They don't appreciate as much, but they eventually will come back. I think that is correct. And I think if you're living in a city and you are looking to buy a place, you're most likely going to be priced out of the market anyway. So, like places like San Francisco, like you kind of already see this where like, okay, well, we're returning back to the city. Well, rents already rose, so we can't afford the same place that we were in before, and for housing prices as well. You kind of see that they are mostly they're getting outbid by other people who have, just had big unicorn IPOs. And so it's kind of like that story as well. And then along with inflation, you're going to see housing prices like continue to increase. So yeah, I think demand for condos will come back. Like people will realize, oh shit, I can't afford a house. I'll settle for a condo. But those prices will rise along with inflation as well, especially if the Fed raises interest rate. Well, if the Fed raises interest rates, the housing price will go down. But until that time, then I think condos and real estate will just keep going up. It's kind of weird. Low price homes represent 36% of investor purchases, the smallest share on record. What the hell? The piece of the pie is shrinking. Low priced homes represent 36.1%. High priced home made up slightly down. So it's mid tier pricing, mid priced homes that are going up, and everything else is like, well, low price. Yeah, no one. If it's low priced, it's low price for a reason. And if it's high priced, well, it's not. You can't really find people to buy it, so because it's an illiquid market. So the other thing are mid priced homes where people are like, oh yeah, well, I want something average. That's my forever home. So that kind of makes sense here. Yeah, affluent Americans from expensive cities have been increasing in home prices in places where they can get more bang for the buck, like Phoenix or Las Vegas. Yeah, I think most people have kind of noticed this trend, especially if you're on YouTube. You'll notice a lot of people have actually moved to like cheaper areas, like Las Vegas. So it's more or less like, oh my god, I can't deal with like the taxes, and like with the pandemic, I can now go buy places somewhere else. So this is kind of a known trend, I think. Investors are more likely than regular buyers to buy homes with high heat drought areas. Wow. Okay. Why high heat is just isn't that just an indication of trying to buy in the South? Like that's like talking about like where they're buying. So that would be Atlanta, Miami, fucking Las Vegas. And if you're in like places like San Jose, like or New York, that's gonna be coastal. So it's just more of a symptom of hey, they're buying in these specific cities, not really anything else. Flood risk down the South, drought risk. Yes, this is like down in the south near Texas. So this is a nothing burger. Atlanta saw bets on mid-sized cities, so the suburbs, sure. Okay, let's see Anaheim. Yeah, holy fuck. Yeah, Anaheim is getting up there. Holy shit. Oh, hey, what's up, man? ASAP Code, what's up? Yeah, we're just waiting in like 4 more minutes for the time. Right now, we're just kind of going through like some hacker news articles. Oakland, people have been buying in Oakland. Okay. Yeah, average price of $1 million. I think Berkeley, California, should be on this as well. San Francisco, yeah, these got snapped up when the pandemic hit. San Jose, same thing, $1.6 million asking price. Yeah, you can kind of see like. People are on Redfin. They are buying in San Jose right now for about this price, actually. So this is kind of interesting. I would recommend that people actually read this. I think knowing what's going on in the housing market is pretty interesting right now, especially if you're into finance. But my take on it is that we're definitely overpaying for housing prices, and if you didn't buy one in like I would say before April, May, before hockey sticks, you kind of already got priced out. So I think the sweet spot to have bought would be like within that 6 month period last year, between like November and March. I think that's really when this would have been the best time to buy. So, yeah. To be fair though, in the areas that they're buying, like in San Jose, it's kind of like there's no fucking there's no way that no one's gonna buy a house. Everyone wants to buy a house here, so. Hey Mike, what's up? Nothing much. We're gonna just waiting for our coaching client right now. In the meantime, I'm just chilling. And reading like hacker news articles. So if you guys have any comments on anything I'm reading, feel free to drop it in the chat. Rip everyone living in California, especially the Bay Area. Yeah, man. Like, fucking. Look at this chart again. Shares of purchase homes bought by investor versus investors in Q3 2020. Yeah, so it's like 3%, like what, 15 to 18% jump, so 10% more activity. There's fucking double in Cincinnati. I would not be surprised if people are buying it. Okay, Chicago is actually not as high as I thought it would be. Year over year changes. Holy shit. And then Florida, Phoenix, fucking Riverside. Wow. Yeah, I guess these are the suburbs. ASAP Code says, what's the best way to learn code? I've been struggling to just sit still and do it. I'm trying to learn PHP, Java, Python, and JavaScript. You're learning a bunch of shit at the same time, dude. That's your problem. It's like, oh, I can tell you, I can't know more than 2 programming languages at the same time very well. 3 at best. So for me, that's going to be Python, Kotlin, and Java. I barely can do Python without constantly looking up the code for it. Java is my primary language, and Kotlin I'm trying to really capitalize on. But even then, it's probably a little better than my Python. So I can't even know 3 languages at once, even though I've been working with it for a year. So my suggestion is learn one language, learn it very well, and actually create a project with it. So I would suggest you do Python because it's the easiest, most flexible one. Do a project that you personally will benefit from, and then just that's the best way to learn how to code. That's my opinion. I learned Python by writing a bot that will value companies for me. And I think I've shown it a few times on stream. But basically, you give it a stock ticker, it will try to project what it thinks the company is worth. And that's kind of like how I learned these things. When I learned Java, I basically hacked a Minecraft client and modded it. Like back in 10 years ago when people had all those griefing clients. Yeah, I was part of that too. I wrote my own client just to learn how Minecraft works and how to write Java. Also, it was really fucking fun to grief people on Minecraft too. So, I work for a pretty large mortgage company, and people definitely haven't slowed down on buying. I started in April 2020, and they keep breaking records in terms of volume. Yeah. I would suggest look at the ratio of offers to buyers. I don't remember what exactly that's called, but I think it's like somewhere on the order of like 105 to 108% ratio of sellers to buyers right now, especially in the Bay Area. Second, I know that up until recently they have, recently they changed the conforming loan limits in the Bay Area as well. So I think from $800,000 to $900,000. So that will increase demand. Third one is because people can like actually buy shit, can buy more houses than they previously could not afford. And then third is that I was gonna make one other point. Refinance rates. Refinance rates have dipped below like 3% in the past like month or so, and only recently have they I think they ticked up for a little bit, and then they're still trending downwards. So I know that if you were like to try to refinance your rates right now, you could get like easily below 3. I know like even for like a conforming loan, you can get like 2.8 or 2.6, depending on how good your guy is, even for 0 basis points. Anyway, let me bring my client on. All right, let's see what he's got to say today.
Recording in progress.
Hey man, what up?
Hey, what's up?
Hey, nothing much. How are you?
Okay, pretty good.
Cool, man. Now catch me up on everything. I think we just had you focus on just really grinding away some leak code questions over the weekend.
No, I wasn't grinding on lead code over the weekend. I tried not doing as many problems, but like tried putting in more time in a couple problems. So I was just doing problems from EPI. I did like I think 6 of them. Two or three were like couple questions that I've like seen like variations of before, or like kind of similar to routing. So it wasn't too bad, but there were like 2 or 3 that were like I really struggled with, and like I really took the time to do the write-ups, but they were pretty time consuming, to be honest. Like I think one of the ones was the End Queens problem, and like I tried to really take it slow in terms of the write-up, because that was the first one I did in terms of writing up. I think I spent like maybe like an hour or 2 just like doing the write-up. It's pretty long. It's in the. I could share my screen, or you could also open up the link I sent you. But that's basically.
See your diary.
Yeah, so I was like trying to be very like detailed about it, and then like I also did another write-up for like the gas up problem. That's a problem from the greedy section, and then there's another one that I have yet to do the write-up, the majority element. I felt like that one I haven't done the write-up yet, but for that majority element, I was pretty much stuck for like a long time. But then like when I look at the solution, I felt kind of disappointed in myself, because I felt like I was like very close in terms of like asking the next questions. I felt like if I could have asked like 1 or 2 more questions based on what I had gone to, I probably would have gotten it. But yeah, I think I was just like practicing. Like I don't know if you could see like based on like the way I practice, I would, whenever I get stuck, I would just kind of start asking myself questions like, okay, what am I blocked at? What are the next logical questions I can ask? And I think I was just kind of like practicing the approach more than like cramping problems.
Perfect. That's exactly what I want you to do. All right, so let's actually go through this. This entire practice diary is from this weekend, correct?
Yeah.
Good. So first things first, the reason why I have you do these details and this complicated write-up is so that way you understand the level of detail that you need to operate at. You know, when I do these coaching sessions, when I talk about like solving the problem, when any of my clients do like a really, really, you've seen like Pablo's diary, right? You see
Yeah,
like
yeah.
he's capable of going that deep if he needs to, but most of the time he doesn't need to write that because he already understands how this all works. And if I ask him at any point, okay, why did you do this? He could go into this level of detail. I'm trying to build this habit for you.
Okay.
So, and you like it's to be super obsessive about the details, and like I guarantee you, you do like 1-2 weeks of these with every single type of pattern, you will get you. This will become second nature, and you never have to do it again.
Okay. Yeah.
Okay.
No, I definitely already do feel like some sense of like um improvement, just not very much yet, just because I just started, but yeah, I see what you mean.
Mm-hmm. Yeah, it's it's kind of it's like that. So if you're starting to notice that, hey, you're able to get through more problems at a faster rate, at a more you're able to like get around what's it called, roadblocks faster or better because of this, then we're on the right path. I just need to know that there's a limit of progress. I don't need you to go from nothing to absolutely perfect in one day. You know, that's not how this
Okay.
works. We're building
Okay.
good habits here, and by building good habits, it's like you have good discipline. By building good discipline, you get good habits. By good habits, you get good practice. By good practice, then you will do very well on these interviews. That's just kind of how it works.
Yeah. Got it.
Anyway, so let's actually see what you wrote up for end queens, since you talked a lot about it. So, no two queens
Yeah.
are in the
Yeah.
same
So,
row, column, or diagonal. Return all the possible attacking placements of queens on an end by end chessboard. All right, cool. We given end queens, we can generate all possible combinations of placing end queens on the board. So this is your naive solution, and then
yeah.
just
Yeah.
mhm,
Yeah. So this is actually like the part when I'm doing the problem. The write up is like
mhm.
after it. Just wanted to make that clear.
Cool. Let's go ahead and I just want to see how you approach the problem here, just very
Yeah.
briefly. Okay, so you address the naive solution. Very fine. I'm actually okay with that. I like that acknowledgement. Very good. Same row, same column. Yep, diagonal, IJ. Okay. So you're doing like
Yeah.
you're just talking about like, okay, here's the different ways to tell diagonals. The okay, cool.
Yeah. Yeah. I think the biggest thing, I addressed this in the write up, but like I got pretty stuck up on this knowledge gap in terms of diagonals because I feel like that's something most people would know going into like some of these 2D array problems. Um, but I wasn't like I had that gap and it was like pretty much blocking me throughout the entire time when I was like doing it, and I felt like I should have like kind of set it aside and focus more on the bigger picture.
Uh huh. Okay, you brute force diagonal. Yep. So this is probably where I would say that at this point, if you can see my screen, this is like should have
Yeah.
been the inside. Hey, I can't do like rows, columns, or diagonals, and so the rows, columns, and diagonals that should be the ultimate rule here. That this is like where I would have
Yeah.
expected you to start off on like and so the question now becomes how do I get rid of all this extra stuff but yeah, let's see your write up. Okay, you're still. I still feel like you're doing a lot more examples here just to try and solidify your idea. The thing is that I want you to be able to do this very visually, very quickly. So again, I'm just like making mental notes right now
Yeah.
of this
Okay.
blocker. Figure out what the diagonal coordinates are after placing a queen. Yeah. So for me, the easiest way to do this. Well, let me ask you this: what is the easiest way to eliminate diagonals?
Like the easiest way is we would do a brute force based on
Mm-hmm.
what we have already placed.
Yep. So I would say that for the queen, like like you said before, the naive solution is try every single possible placement of the queens, right?
Yeah.
And then just see if they conflict and validate them.
Yeah.
So then the reason why that's not optimal is because hey, I'm trying a bunch of positions that should have already been eliminated. So like for instance, if two queens are already attacking each other, I don't need to keep trying everything else after that, right?
Yeah.
So all I need to do is, when given a position, eliminate all the horizontals, eliminate all the verticals, and eliminate the diagonals around that, and then put the queens on the remaining available positions.
Hmm.
Does that make sense?
Yeah.
And my question to you is, did you get to that position, or how did you? What was your train of thought?
So I think I did right. I did get to the point where I was like, I did acknowledge that we definitely don't need to check row and columns because those are like easy. Like we can just rule out the rows and columns. But like it was just like the diagonal that like got me caught up, like kind of distracted me from like solving the problem holistically. And that's why in the write-up I also mentioned like in the future, like I could probably like just like put it aside and say like assume we have like a possibly like a helpful function to kind of like figure out the diagonals and kind of focus more on like the problem itself. And then once I solve it or have like a more solid idea, I could come back to it.
Okay.
But yeah, I do acknowledge that like rows and columns. Once we place a queen at a specific row and column, we don't need to try those
Okay.
rows and columns anymore. But it was just the diagonals that I was like locked on.
My problem is, why are you getting hung up on the diagonals? That's my question. Because all it really is just a bunch of coordinates and saying, okay, well, now that I have placed a queen on this coordinate, what is the diagonal? What are all the coordinates that are diagonal to this? So my question to you is, why was that not coming to you immediately?
What do you mean?
So
Sorry.
you need to eliminate diagonals, right?
Yeah.
Why is computing the diagonal on a coordinate taking so long? That's the first question.
Yeah, that was the thing. Like I was like pretty bad on like I just generally I'm like weak like on like 2D arrays, and so like trying to compute the diagonal, and like I think like I was using like I and J, that kind of messed me up when I was doing my examples too. Eventually I did get to the conditions, but it just took like a long time.
Let me see if I can try figuring out like what you were thinking here. Let me go back, because this is like, this is saying that there's a fundamental problem with you're relying a lot on not even visually looking at the problem, or this is very bad. Let me look. Using differences. Okay, you're trying random shit. Okay, I see. That's one. I'll explain to you later what's going on here. Oh, no, okay. Okay, I can tell you what's going on right now. I can see. So first thing first. Knowledge gap in diagonals. There is nothing special about a diagonal. So for me, I would say, okay, so you came up with this example, right?
Yeah.
And so how do you declare? There's 4 different directions that you can go in for the diagonal, right?
Yeah.
And you already know that in order to go right side on the X position, you just have to just everything that begins with a 1, right?
Yeah.
Those are now eliminated. Everything with a Y, that's now eliminated, right?
Yeah.
That's the column. Now the diagonals. This coordinate here is just +1 of X plus 1 of Y.
Yeah.
This is just -1 of X plus 1 of Y. And then et cetera, et cetera. And you can just throw that, you can make a loop with that. So what's my point here? My point here is that you're looking for a magic bullet about diagonals. It's like, oh, maybe there's some fancy like graph property or some fancy 2D array property about a diagonal. I think that's what I was like thinking like, okay, if I could generate like quick examples and look like the what the diagonal coordinates are, I could come up with like a generalized way of checking, for example, like absolute differences of like X and Y of like the first coordinate and the second coordinate. So that was what I was trying to look for, like a generalized condition to check for diagonals. That's what I mean by magic bullet.
Is that not like something I should be like doing though? Like if I were to like want to check for diagonals?
The reason why I say it's a magic bullet is because it's blindingly obvious what the what the basic case is, right? Like you understand intuitively that, hey, the diagonal, like eliminating the diagonal from 1, 1 just involves adding 1 and 1 to the rows and columns, and then eliminating up here is, as I said before, like -1, -1, and then that thing. And then what you decide to go for is, instead of just accepting that as a solution, you're trying to just jump straight ahead to, hey, maybe there's just some fancy property that will allow me to bypass all that. That's magic bullets.
But I was trying to like, so I acknowledge the brute force, and the whole point of the brute force being inefficient because I'm scared. Like if I were to do that whole like four directions of the diagonal, like that's the inefficiency of it, right? And that's what I was trying to look at, because once I address the brute force, which was like generating all combinations. I know like the inefficiency was just like scanning through like columns and rows and stuff. And so like for rows and columns, I know that I could eliminate that inefficiency by just keeping track of like what rows and columns we have placed like the queens up to now, and I could skip them. And then the only thing left was the diagonals. And so I was trying to like find that, well, yeah, magical or like the generalized condition to filter that out, and that way I could not have to do the brute force
Or instead of
solution.
keeping track of the queens, why not just keep track of the remaining valid spots that you can put the queens at? That's my question. Why?
Let's see. I believe I did right.
You just remove them from the pool, and then you backtrack.
So like yeah, I also did think of like placing. So basically, if you scroll down to like the end of page 2, the general idea is that I wanted to like place the first queen and then recurse on the remaining board. And like yeah, like I did also think about like, okay, what if we are able to have like a set of valid coordinates to place the next queen, but then I wasn't quite sure like how I would eliminate the diagonals from that like valid set of next coordinates I can place. I know I could eliminate the rows and columns from that, but not the diagonals, and that's why I was like,
What do you mean? You already know how to generate the diagonal. You already knew how to do it, and you just decided to go for the magic bullet. Remember?
by generating, do you mean like once I place a queen, I would just like go in like the 4 directions to generate the diagonals?
Yeah, that's it. Why not do that?
Because wouldn't that be inefficient?
What? Okay, so what's inefficient? Let's explore that. What's inefficient about it?
So say I place a queen right now, and I generate all its diagonals.
Yep.
I have to basically iterate through like say if it's like a big ball, I have to go like in all 4 directions until I hit the edge. And then I recurse on the next queen, and then so on and so forth. But like say if it's a dead end, I have to backtrack.
Yep.
When I place the next queen, I have to do the same exact step of like finding each like going from like that queen's position to the edge of the board.
Yep. Yeah, you have to do that.
Yeah, and that's what I was like trying to not do. Like I knew I could do that. Like I knew I could like, you know, if I didn't care about, I could just like place the queen, and then like obviously like the row and columns are easy, I could just save them. But I would just need to like go to 4 edges to get the diagonals.
Okay. So you knew what the answer was, and then to me it's like, okay, you're trying to improve on it, but then you're going, but this is what I'm talking about again, magic bullet. It's like, well, what other fact are you going to use in order to come up with this optimization? Because the reason, and this goes into a little bit of logic and inductive versus deductive reasoning, but essentially you take 2 facts, right? And then you combine them into one new fact, you know? So it's like all bears are, let's say all bears are white. And then let's say, let's just say Foo is a bear, therefore Foo is white.
Yeah.
Same thing here. It's like, you know that there's something in here that works logically. You need one other observation that you can combine with that, at least, in order to make that new case of, oh, this is something even more optimal. And so you got hung up on the optimization here. And I'm pretty sure if you look, I'm pretty sure that there is no extra optimization here.
I believe they would still check, like they would only check the previous queens, so on EPI, and then they would do the absolute difference between the previous queens and the current queen that we place. It's down in like page.
Okay, so this boils down to a math trick then, and that's fine. So I see. So instead of iterating, you were talking about a math trick. Okay, that's completely.
Yeah. It's the math trick, like where you could like use the coordinates, and that's what I was trying to get at, because like I knew like, you know, like right off the bat, like with the brute force, I have that I don't need to go through all the rows and columns, so that I could optimize. Now the only thing left to optimize is the diagonals, and once I have that, I could start writing the algorithm, and that's why I was like so hung up on it, because it's a math thing that do not know, and that's what I meant by
Okay.
a knowledge gap.
So then, in that case, it would just be a question of if is it on a linear. You just model it as a linear equation.
Sorry, what was it?
You monitor it as a linear equation. You take the difference of the x and difference of the y, and just see if the
Yeah,
slope
yeah.
is 1.
Yeah.
Okay. Yeah. So so in the question now, I would say that's a pretty stupid math trick, but it's like I get it. So it's more like just remembering your algebra. There's not really much of a trick here. It's really do you know your algebra or you don't.
Yeah. I think that was the thing, and that's why like and you know when I was doing the problem, I was like trying to come up with that, and that's why like like I wasted so much time on this problem. But like in terms of like intuitively, I know how to solve the problem, but I just wasn't able to do it technical wise in optimal solution.
Okay, that's fine. I mean, as long as you got to that point pretty easily, very quickly, then I'm actually okay with what you did here. I would say the algebra trick is kind of stupid and would probably require a hint. Even I would be like, I would probably have overlooked that myself. I'm not gonna lie. So I'm not gonna fault you for that either, because I think it's just mostly recognizing, hey, what if you did this instead? But I think that if you can make the logical progression through what you need to do, you're on a good track. Don't worry about it.
Yeah. So yeah, with the final explanation, that's like my high level like how I would explain it to a 5-year-old. I think it's on the end of page 3.
The pseudocode?
No. It has a final explanation right above that. I would basically, I would place a queen at the current index and try to recurse on the rest. And then if we could place all queens, add to answer. If not, then skip. That was the, like I just wasn't able to come up with that math trick.
Okay, that's fine. And I said, like these are like that's like a stupid math thing. I don't care about that, and I don't think, and I wouldn't be hung up on it if I were you. It's like it's good to know your algebra, of course, but it's like But it's I think this is okay as a final explanation. Place a queen at the index, blah blah blah. Move on. Yeah, okay. I'm okay with this actually. So I understand like where you came from. Bottom line, I would say that. Yeah, I mean probably this should have taken you like only 30 minutes to do. I think. If you didn't get hung up on the algebra thing. Is that right?
Yeah, actually, like eventually I actually got the math like trick without looking up, but it was just like, it took me like a long time.
Yeah.
To compute that.
Yeah, I don't blame you on that one, so I'm okay with it. I get, so the write-up, I get, this is just purely an exercise for you to get the details, and I kind of want you to do this for like one more week. Or at least a few more days, and just so you understand like what it takes to do it, and that you could make this a habit.
No, actually, like I do. Yeah, I do find it helpful. I do plan to do it on like a couple more problems that I do think are challenging. Like I think it's just worth doing.
Okay, power stat. Let's see. Anything that you want me to mention? You want to talk about here?
No, I think not much. Mainly it was like the queen's problem. Maybe perhaps the greedy one. I think the gas up problem. That was an interesting one. I feel like I have a solution, but it's different from what EPI has, like in terms of approach to.
The three-sum problem. Is that?
No. The one below that.
Gas up. Okay.
The next one. Yeah.
Okay.
It's a greedy.
Okay, go ahead.
So like I wasn't able to like really validate it, my answer like on LeetCode or anything. Like LeetCode has the same problem, but LeetCode's version doesn't guarantee like an ample city. But EPI's question does guarantee one, and the solution I eventually came up with does work when an ample city is guaranteed, but it's still very different from what EPI did.
What do you mean by ample city? First, let me ask that.
So that's according to the question. An ample city. So basically, like you given a list of arrays, and 2 arrays, and one is like the gas you can fill up in each city, and the other one is like the distance to travel to the next city.
I see.
Yeah.
Cars unlimited capacity. The amount of gas the city sum up to total go around the road at once. Gas to the car. Okay. Try every single city with 2 loops. I would have. Okay. I guess. Two arrays. Do you have the gas available? And then are you trying to see if a ample city find the ample city or a ample city?
You need to. So you have to find the ample city, because in EPI's question you are guaranteed an ample city.
Okay. To me, I look at this problem. Here's how I would have solved it.
Yeah. Okay.
So basically, if you can start and stop at a city, then
Yeah.
that means that the path that you take must also be in that circle. So let's say I go from like city 13579 back to 1, then I know that if I am anywhere on that I can actually get back to that
Actually,
any one circle, right?
no. This farm is so it's only one circle. Every city is in that same loop, but not every city guarantees that you. If you start from like any random city, it's not guaranteed that you have enough gas to get through the whole loop.
Right. I'm saying that in theory, if I had that, if I could find a loop of circle city 13579, then I guarantee that I tag any point in that any city in there, I'm good.
No, actually, like if it's 1375, it has to be you have to start at 1. If you start at 7 or 3 or 5, it's not guaranteed you can actually get through the loop.
Oh wait, let me see why is that? I'm saying that if that was the case. So explain to me why. Explain to me why. Let me ask that first. The amount of gas.
So you're saying if the answer is 1357,
yeah,
you can start at 3 or 5 or 7.
Yeah, and I should be able to get back to 7, right? Or are you saying that's not the case?
That's not the case. Look at the example. So the answer. So that's the example. The answer is the fourth element. So at 30.
So at the 3.
Yeah, 30. Yeah, 30.
30
so
30.
1 gallon allows you to travel 20 miles. And so if you start at that city, you could travel 400 miles. You fill up 25, and then you go another 600. You fill up 10. You go another 200. You fill up 10. You go another 100, and then you go back to the beginning of the array because it's like a circular loop. And you're able to go back. You're able to get back to that city where you started. Now that is the answer, right? But say if you started at 50, you will not be able to even get to 30.
Ah, now I see. It's not so. This is not a graph. This is like literally just going to the next index.
Yeah.
Okay.
Yeah.
Okay. I mean that's fine. Okay. Yeah. So the obvious way, try every single city with 2 loops. I would say with 1. Oh yeah. I see.
Yeah.
Tried both ways. Didn't seem helpful. What do we know? We need to try the current city. Sufficient graph to traverse the rest. I'm asking the right question. If we start at the current city, what? Okay. This means the current city, we need to know how much gas we have. Efficiency is the fact that we need to retry adding up the gas and deducting the distance. Sure. Current negative element is... Okay, so let's see the difference between each individual gas element. Okay. So this is your gas, this is your distance, right?
Yeah.
And you're saying that you fill up, let's say you start at 0. The difference, what's this 5 difference? The difference between gas and distance? Okay.
Yeah, so I converted the miles to like I would divide it by 20 because 1 gallon gives you 20 miles. So I would just like see this, and from here like we know that if like for example like the second entry, it starts with a negative 10, so we know we don't even need to try that study. So I was just saying like okay, if current element is negative, we can skip. And based on this, like once I condense it down to one array, I could kind of like plot this like I could kind of like picture a graph in my mind, and it's like okay, I know that once it goes below 0, that's when it's no good.
Yep.
And so I basically need to be able to start at like a 0 or like a positive element and come back to it as I add up the elements without ever reaching 0. So that was like my idea, and like I tried it and actually works with like the question, but then like the approach that EPI took was like was a completely different one.
I mean, I don't mind this one. This one looks correct actually. I would definitely try and test it on other things. But then did this work with like LeetCode submission?
No, because LeetCode's one it's a little different. LeetCode's question is that it doesn't guarantee an Apple city.
Okay, I think your reasoning is correct actually. But let's actually see what EPI did, and let's compare.
Yeah.
And then you said this is which chapter?
Greedy.
Greedy. So the gas up problem 18.6. Cool.
Yeah.
Let's take a look. 343. Okay, so let's see what they did. The
Yeah.
brute force, yeah, so they did come up with the n-squared solution like you did. Okay. We can gain insight by looking at the graph of the amount of gas in the tank will become negative, or physical impossibilities, yeah. We consider the amount of gas in the tank is minimum when we enter the city. Observability does not depend on where we begin from because graphs. Okay, sure. So this is just this graph is meant to represent, hey, we're meant to represent refilling.
Yeah.
So you
So,
did. Mm-hmm.
yeah, so their reasoning is that we need to find this city that we go into with the minimum gas before we refuel. That, therefore, like if we started that city, we would never actually go lower than that because that's the lowest amount we ever have going into it. So I feel like their reasoning was pretty clever. And like, I think like the reason why they like the only thing I wasn't like, I feel like the reason I wasn't able to come up with that was that when I look at this problem, I know it's greedy and I know like I need to make a decision at each point, and I kind of need to know like how the increase and decrease works. But like as I was writing out the examples or testing out the examples, because I don't have a graph, right? So I was like computing the values, and I would just write the end value of like after refilling. But if say I had the graph of like what we're looking at right now, I think I would have been able to deduct that, okay, it seems like D is the answer and Y is that, and like what is the one characteristic that makes it stand out from the other. And you see that at D before it refills, it's actually at the minimum point. So if you start at D, you wouldn't go lower than that, and therefore allows you to get back to it because you're guaranteed an ample city. But I think like them being able to plot out the graph was like the main thing.
So
but whereas
like going into the city with the least amount of gas, that's their answer. Oh, I see.
Yeah,
I see what they're doing, huh? The thing is that I think yours is just pretty much the exact same thing because this is just the summation of all the differences up until that point.
Yeah,
it's more or less the same thing.
It's I agree. It's more or less. It's just I feel like that one, the one they have is pretty clever. But so nonetheless, I still did a write up for that.
It's like one of those things that's like, oh, okay, that's a pretty clever trick, but it's not something that I would expect to be systematic. I think it's like a good tool in your toolbox, like it's like the difference thing, like you did is good. But then also like, oh well, what happens if I tried like keeping track of things then before I went into an actual index? I think that's fine. So yeah, I would say that if I were you, I wouldn't be too disappointed. Again, this is just another tool in your toolbox.
Yeah, but like I wasn't too disappointed on this one because I only took like 35 minutes on the gas up one.
And as long as you can argue that your solution is good enough, like then it's fine.
Yeah, it's the same complexity, just different approach.
Sure. So then I would say after that, I think you're on the right track. Let me look at your schedule. Okay, so this week is the 15th. So you did recursion and greedy. You're feeling pretty good on recursion and greedy, right?
I would probably do a couple more. I feel better, but I don't feel like fully ready. If anything, I would still do a little more, but I wouldn't be like fully on it. Depending on like what if you give me like new topics to work on. Otherwise, I would just continue on it.
I'm gonna say continue on it for a little bit more. But I think you mentioned that you're really bad at arrays, right?
Yeah.
Even though we did it a week ago. I don't know. So let's do
this. I would go back to it because like when you first made me do arrays, I wasn't doing like the write ups and stuff. So
okay, I'm gonna make you do the write ups.
I feel like it might be worth going back to it.
Okay, and then it's like we might even want to explore like redoing these because you didn't do it the right way before. I thought you were doing the right way before because you were doing the replays, but it turns out you weren't actually like trying to figure out how to improve yourself. That's the big difference. So that was an attitude problem. All right, that's fine. We can redo that.
Okay.
So, sure. All right, let's settle on this for now. And I do want to talk to you about testing and get you a little bit more efficient on that.
Okay.
So when you're testing like code, right?
Yeah.
So let's do this. 11:15. So code testing. So I think I mentioned to you like the idea of states before, correct?
Yeah, you did.
So let's say I'm trying to test, like, let's say a recursive, like a tree, right? So there's a bunch of variations and vector states that I can test against, right? There are the possibility that I have a parent, no parent. I have a no child, child, one child, two children. And then some permutation thereof, right? Because in theory, I could have a parent and no child, which would be a leaf. I could have parent one child, parent two child, right? And then on top of that, there's like the null case as well. And then after that, it's like times whatever the star, and then whatever variable inputs you have. And so the idea is that you want to be able to break this down into a, into a state, or I should say into a few states that represent all numbers. And this is like kind of like based on your code, right? So let me give you an example. Let's say that I was traversing a tree, right? And then I had a node here, and then I was going to say, okay, well, and then I passed it, actually, let's say my function here, right? I passed it a node n, and then I have an integer x, right? And then for int, let's say if x is less than, let's say 50, perform some operation, right?
Yeah.
And then other than that, like function node.left, node function node.right. And then let's say I do some operation with the node, right? This is just a general example. So the reason why I bring this up is because now, like, okay, well, I need to make sure all the possible states my node can be in, I need to make sure if this code can handle if node is null. It needs to be able to work if the node has a child or a parent. But in this particular case, we're not evaluating the parent.
Yeah.
So we don't need to worry about that. So we can actively strike that out, right? Do I need to worry about one child or two children or no child? Yes, actually, because I'm going into the left and right. So I need to be able to handle the possibility that there is 1, 2, or 0 children, right? I also need to handle the possibility that n is null. So I'm not doing that. So I need to do if n equals null, then do.
In this particular example, if we handle n equals to null, we wouldn't really need to handle whether n has children or not, right? Because if it doesn't have a left or right, when it goes into it, it would just return at the null.
Well, what happens if n does have children? What happens if n is not null? Yeah.
Then we would just do the operation at the node.
Keep in mind, operation could be anything. Operation could be print if for all I care.
Okay.
I'm just using this as a hypothetical. This could be like, or add things to a hash map. This could be anything.
Okay, I see.
So it's like if I say print null, then it'll just print null.
Okay.
This again. So that's what I'm trying to illustrate here. It's like if I handle null, then then it's all good, right? Maybe my operation can handle null by itself, but maybe operation or may I do something like print object.value, right? And then you have to do null check in here. But personally, for me, I like doing it up here because like 99% of the time, you don't want to do an operation on a null thing, or you want to segment it away from the rest of like what you're doing.
Yeah.
So that's just kind of like good. It's just good practice, and you'll understand. I think you'll understand this better as you progress through your career. But basically, I like almost always avoid the null case if you can't help it. Like get rid of it early on. There's almost no benefit to doing it. Okay. Anyway, so my point here is like you're basically just trying a bunch of states here. So in other words, our test case will be like null, and then the 0, 1, the no child, 1 child, 2 child, and then we would also want to test if x is less than 50, x is greater than 50 as well, or equal.
Yeah.
So these are like our 4 cases, especially because we want to make sure that this works. Because each of these are actually independent of one another, right? I could have statement A, statement B, statement, and let's say C here, right? All these don't have any bearing on each other, right? So let's say I pass in null and then x is 50, right? Let's give an example, right? N equals null, x equals 50. This is not really a different test than if I had n equals to, let's say n equals to a node and x equals 50. Like, I mean, technically this does test this part instead, or let's say n is node 1, right, with children, and let's say the node is node 1 without children. Actually, this is a better example. Let's say I pass a node with children, pass a node without children, right?
Yeah.
Well, in theory, they do test things that are different. They actually test this chunk, but this 50 here doesn't really make a substantial difference. So in theory, if our goal is to bulletproof this area, these two tests do not make a difference because they're testing the same value of x and it's independent of node. But if I'm testing for n, all the possible values of n, like 0, 1, 2 child, right? Then it does make a difference. Do you see why?
Yeah, because it has the children.
Well, not just because it has the children, but because the code that evaluates the children is actually here. It's completely separate from the code that evaluates if x is less than 50.
So yeah, it's almost kind of like imagining like my one function is breaking down into like multiple helper functions, and I want to write unit tests for like each of them to evaluate that each unit is doing what it's supposed to do.
Right, and it depends on what is what this code execution is dependent on. So for instance, if I change this up to like a node equals to like node dot val equals to 10, right? Just as a hypothetical example.
Yeah.
Now this becomes substantially different because not only am I relying on the value of x, I'm relying on the value of node as well. Now this changes the testing dynamic because this operation here, if I'm trying to test if whether or not it gets executed, is dependent on this factor. Does that make sense?
Yeah, it is.
Okay, cool. So with that, I want you to keep this in mind when you're actually testing. This is just like one example, but really think of like making sure you cover all your cases, making sure you cover every single possible state your code could be in. And in the past, what you've been doing is like throwing random examples. I want you to think more objectively. I want you to think more in terms of like, hey, what portions of my code does my code rely on, and how do I use a proper test case to relay this? Does that make sense?
Okay. Yeah, I just feel like with certain problems, like I think with tree problems, it's a little more obvious. But then with like certain problems where the algorithm might be a little more complex, it may not be like super obvious to me of like some of these like edge cases, and I might end up missing on them. But I'll definitely keep it in mind of like the testing each code or like each part of the code.
Yeah, it's not, and also making sure that the tests that you come up with are meaningful and that they do encompass like what you're trying to do.
Okay.
And it's, like, keep in mind like what part of the code are you trying to test, what piece, and then what are all the possible values that you need to have in order to achieve coverage. So let's actually do this. This one's gonna be it's a very good test. I know this is gonna be very simple, but I think it's I want you to keep in mind how you want to test this because if you test it wrong, you will get tripped up. So have you might have seen this one. Remove duplicates from two sorted lists, or from
I've seen.
Okay, you've seen this one. All right, different one then. I've given you red tape, blue tape before.
Yeah, you did.
Good. Validate binary search tree.
No, I don't think you've given me that one.
Okay, have you done it before?
No, I don't know. I don't think I've done it before because I don't think I've heard of a bounded binary search tree. So
no, validate a binary search tree.
Oh, depends on like what your question is asking. No, but I've not done it recently.
It's a problem. So you know what? Let's do it with the problem then, because if you're familiar with it, but we want to do it with a clean approach. We want to do it with a clean thought process and clean testing. And I really want I want you to focus on like what we're trying to do here today. I want you to focus on the testing.
Okay.
So let's go ahead and do this. So given a root of a binary tree, determine if the binary search tree is valid. And a binary search tree is valid if the left subtree of a node contains only nodes with keys less than the node's key, right? And the right subtree contains only nodes with keys greater than the node's key, right? And then both left subtree and right subtree must also be binary search trees as well. So I'm not going to put a timer on you, but I am going to critique how clean your approach is. So yeah, I think of it as you have infinite time to be as efficient as possible. Okay.
Okay. All right. So given a binary tree, you have to determine if it's a binary search tree. Okay. So based on like the three conditions, it sounds like the third condition is essentially, let's see. Okay. So if, let's see, how I'm trying with this. Okay. So first condition, second condition. Okay, so whatever validator we have, the left, right subtrees current node need to be able to pass as well. And seems like on the first and second condition, I think in general, this sounds like we want to make sure the current node is within some kind of range. So we can say like the node is between a minimum and a maximum. Now, how do we keep track of that? Well, we can come back to it later, but it seems like that's what I'm seeing right now. So in terms of at this point, should I like start talking about like what are the different cases we can test, or should I like develop the idea more and like talk about like the different test cases after like I have like a general idea or algorithm?
I want you to have the general idea first, because you don't know what you're testing until you have the idea, you know? So
Okay.
that's fine.
Okay. Let's see. Root. Okay. So obviously, like when we begin the function, I know like if it's an empty root or tree, we can say like it's true or valid. What else? And when we first begin at the root, in order to determine if it's valid BST, we need to validate its left and right subtrees. And this kind of trickles down all the way to the leaves to make sure like it's valid. Otherwise, we just return false. So let's see. Okay, and looking at the first and two conditions, contains only nodes with keys less than the nodes key. Okay, so if we're gonna keep track of like the minimum maximum as we passing it down, I would imagine that we would need to kind of pass like when we traverse the left, minimum would stay the same.
Okay.
The maximum would be current node's value. And for the right, it would be kind of like the inverse of it, where minimum is the current node value, maximum stays the same. So this is like pretty much like it. So say like we don't handle much like empty cases right now. This is like how I would kind of validate the values. Now let's see. What about empty?
Okay.
Yeah, I'm just trying to think like about like empty nodes or like empty childs. But in terms of like if say I was given a complete tree, then I think that this would essentially just work to validate it. Now if a subtree or like a child node is null or empty, we just say that's valid. We would
Sorry, repeat that.
So if a node is empty or like null, would we say that's like valid?
Yeah, well, let's just say it's a single node. Yeah, we're good. Yeah.
Okay. Would we be given a tree with say a right node but not a left node?
You could. I mean, you could have that.
Okay, I guess in a valid BST, it doesn't. Okay. Sorry, this is valid binary search tree, so we don't need to care if the tree is complete or not, as long as like the nodes values are valid. Okay, so the idea we kind of have is if empty tree, we can say valid.
Okay.
Otherwise, we start at root and we validate its subtrees recursively based on a range. That's pretty much like what we're going to be doing from a very high level.
Okay.
So should I write the pseudocode before I talk about like test cases, or?
I would say if you have a very good idea, pseudocode is just meant like, hey, it's just an exercise, right? When you go to do the actual interview, you're not going to need it. But if you feel like you still need the pseudocode, I would write the pseudocode before I test the idea.
Okay. This should be like fully comfortable. I'm just gonna like kind of write out some pseudocode.
That's fine.
So we're gonna have like so validate root main function. If empty, we just return empty. We say valid. Else we recurse on left and right. Now let's see if I were to use the same function for the trees. I need a helper function. Okay, I'm just gonna write out the helper function and see like how if we could eventually. So yeah, we're just taking a node minimum, maximum. Now, if not node, we can just return.
Okay.
In this case, we don't care. Actually, yeah, we return true actually. And yeah, if the node is not empty, then we want to make sure node is within range. If not, we return false. After that, we have to recurse on left and right. And I say and because like if either one of them returns false, then we want to say the entire tree is not valid.
Okay.
And okay, let's see what are the different
I
test
do want
cases.
you to make a note of that, by the way.
Sorry, what was it?
You said that if either of them return false, you should return false, right? I want you to actually write that in your pseudocode.
Okay. If either returns false, we return false.
And do you know why I want you to write that in?
So that when I write the test cases, I could write a case that tests that.
I mean, more importantly, in terms of the context of actually problem solving.
Okay, so that I don't eventually forget about it or like.
Yeah, because you're trying to solve the problem. Yeah. I kind of want you to come up with a solution for it. So.
Okay.
Yeah. So if either return false or say the entire tree is valid. So then, is there a solution when we return true?
Yeah. If both are true, then we return true.
Oh, there you go.
Yeah.
See, you just be complete about it.
Okay. Yeah. So that's pretty much like the pseudocode I have for checking when given a root if a entire tree is valid, a valid BST. Now let's see what are the different test cases we have. Obviously, like we want to test like the empty root. Let's see, and then we have a non-empty root, but without I guess yeah, a non-empty root, but without would it be redundant without children? Okay, let's just say we have a node, and then we have no child, one child, children. This is
okay. So you're testing the empty node. Yes, you're going to test a node with no children. You're going to test a node with one child. That it's invalid or valid too. Okay, sure. Reasonable.
Yeah. So should I actually run it with like write the code out and like test it with like actual examples written out, or should I go ahead and?
Okay. I would say that for the most part, with the way I do this, and everyone else can feel this way differently. But personally, for me, I like to do a brief smoke test. Make sure that my test cases are covered, and that make sure that my idea is okay, and then do a thorough test later with the code. But I just like doing a previous smoke test just so I can modify the pseudocode, and because it's a lot easier to modify that than it is the code itself.
Yeah.
So.
Okay, we could just go a quick scan through this list. Should be quick. So empty root, we simply return at the main function. We don't even continue. Say the root is not empty, we go in. We're testing no child. And since we're recursing on both left and right, both are going to return true over here. This is good. We say it's valid. If it has one child, we only go into it. The other child is going to return true, because we know if it's empty, it returns true. If it's false and invalid, over here, the same condition is going to apply. So we know that it's gonna return invalid. If that non-empty child returns true, then we know it's valid. Say we have two children. We basically check the range. If it's false or true or not, okay. And then yeah, I think it seems good to me. I could go ahead and code it, and we could do a thorough test later.
Okay, go ahead.
That sounds good to you.
Seems like you're
Okay.
code it, then go.
Minimum, maximum. So minimum, let's just say we pass in this, and maximum would be current value. If it's okay, if it's less than minimum or greater than maximum, we can return false. Let's see. I think that should be. I'm just gonna take a quick look to scan through it to make sure everything's okay.
Sure.
Not root, return false. Then we go into the tree. This is minimum, maximum, okay. Good. If it's smaller, greater, false. Okay. Left. Okay. Yeah, I guess we can like run through like a thorough test to make sure everything's good. Coming here, okay, we know that empty root, this is fine. Oh wait, empty root, okay, I see. It's okay, so empty root, we return true. And then once that's done, we go into the child.
Okay. Cool.
And say like in the first test case here where we have a non-empty root but no child, both of these are simply going to return true over here. So that's going to be a good BST. Now say if we have one child, say this one is just going to return true because this is empty, and this is the other one. If this is empty, or like if this is invalid, now what I mean by invalid? So let's see. If we go in, if it doesn't pass this condition, we return false, and therefore true and false, we return false. So that's good. If it's true and true, this is good as well. If we go in, it has two children. We run the same function against it, and then we simultaneously kind of call that on its remaining children to trickle down. So I think, yeah, this seems good to me. In terms of like time and space complexity, since we are basically scanning the entire tree.
Mhm.
Each node we process it once. We would just kind of add up to O of n.
Mhm.
As for the space, say this was it's still a valid BST, but it's almost like a linked list where it's skewed to one side. The recursion stack could kind of add up to a O of n.
That's worst case
Oh,
scenario.
yeah, O of n. But I guess like in this is worst case, but say in like an average case, it would just be of log n, which is the height of the tree.
Mhm.
Yeah.
Okay. Okay, I think that's fair. Let me ask you this though.
Okay.
Having done that, that's a pretty clean way, I think. How'd you feel
Yeah.
about doing it?
I think like doing it. I think like talking about the different states, kind of allowed me to test it way better. I think like that's where I caught the like here initially I had that
Mhm.
callous mistake of like returning false here. So I think like if I didn't like write this out, I
Mhm.
probably would just assume like I didn't make that mistake and just be like, oh yeah, like I think empty no return true. This is good, and then like kind of wing it.
Mhm. Yeah, but like having that is going to be a very good guardrail for you. So,
Okay.
and the solution was pretty clean too, and it didn't take you that long to do this problem. It was like almost like 10, 12 minutes or something like that.
Yeah, I think with tree prompts I am a little more comfortable.
Mhm. Okay, so do you want to do a non-tree problem?
Sure.
Yeah, it's gonna be the same. It's almost the same exact idea, by the way. So
Okay.
let me go ahead and okay, this one's gonna be pretty easy. Given a string S containing just the characters open parentheses, close parentheses, curly bracket, and square bracket, determine if the input string is valid. I think it should be pretty easy.
Okay.
But I
What
want
do
you to do.
we?
I don't want you to be super careless about this. I want you to like be clean about it.
Okay. What do we mean by valid here? Are we basically checking like the like say this is valid, um, this is valid, but this is not? Like what do we
Yeah.
mean? Are we talking
So
about
for every
the
open, there's a corresponding close that is proper. So for instance, I want so think of it this way: like if I have open parentheses, close parentheses, that's valid,
yeah
right? If I have this,
yeah
that is not valid.
yeah
Okay, there you go.
okay okay. So yeah.
And don't worry, after this
Um,
problem, if you get it right, I think we can shift gears to system design.
okay okay. So obviously like the like with this question, I think like we can every time we so let's actually let me make this out. So we have three different types of open. So we have this, and that, and then right we have this, and that. So what I'm thinking is like if we see a left or open,
Uh-huh. Hello? Damn. Hello? I think he's cutting out.
character, we
Yo, you
save
kind
it
of cut out for
in
the
fact.
entire time,
So we
by the
can look
way.
at the last one. Character. We have two cases. Encounter any left. Oh, if stack is not empty, we also have two cases here. Now, if it's matching, we know this is valid. We can actually pop that, so we don't have to care about it anymore. Now it's not matching, we say invalid.
Okay. By the way, you kind of cut out for that entire thing, but let me quickly read.
My okay. Yeah. This is just simple. If I see a open character, I add it to a stack. If I see a closing character, we have two cases: one where the stack is empty, one where it's not. If it's not empty, if it's empty, then we know this is already invalid because we encountered a closing character without a corresponding open character.
Okay.
And if it's not empty, then yeah, we also have two cases where one is matching, the other one is not matching, and from there we could determine if it's valid or not.
Okay. Now I want you to think
yeah.
about how you want to test this. I think your idea is good, but I want you to see how you test this.
Okay. So test cases. So should I just be like pretty generic with like what I listed up there, or with this example, should I kind of write out like actual concrete examples?
I want you to tell me. Let's do it this way.
Yeah.
You do
Okay.
what you think is right, and then I'll adjust you.
Okay. So test cases, obviously, what I think is like empty string internal, and then we have a okay, and then we have a valid string and invalid string. I think like what we want to test is actually the invalid string. We're more interested in that because there are more cases to test. So let's see, we are returning invalid here, invalid here. So one where it's like encountering a closing character without a open character before. Encountering a closing character with a non-matching open character.
Okay.
Let's see what else.
What kind of string? So okay, actually, go ahead. Go ahead. Yeah.
Yeah. So example, this would be something like it could be this, or it could just be that. You know, it's pretty much the same thing here. And this one would be something like we have like corresponding open ones, and then suddenly we have something that's not matching. And valid could just be like, you know, any valid string. Yeah. An empty string would just be this. So looking at this, yeah, and in the end we would basically use this. We could also use the stack to determine if it's valid or not. If it's empty in the end, then we know it's valid. Should I go ahead and like begin coding this?
Yeah, sure.
Yeah, I feel a little more confident in this, so I'm not gonna do the pseudocode.
Sure.
So I'm gonna begin writing this out. Valid string. And like I mentioned, if this is empty, we just don't need to do anything about it. And yeah, we have a stack. And like I mentioned, we have, so if we have like a lot of these open and closes, we can obviously store them in like a set or hash map to just keep track. But I think like in this case, since we only have 3, I'm just gonna kind of like write hard code the conditions out.
Yeah, do what you need to do.
Okay. So let's see. Char and S. Now, we know if we get here, then this is a closing character. Okay, if not stack, we simply return false here. Now, if stack, we have to check the matching one. So I think this is where we need to do all the hard-coded conditions. I think, let's see, I might just do a hash map just for the matching.
Yeah, hard coding is gonna be kind of hard. So just write it out. I know it's kind of a pain in the ass, but it's kind of unavoidable.
When you say write out, do you mean do you want me like hard code it out, or
yeah,
like...
yeah, the matching conditions like open parentheses need to match close parentheses, etc., etc.
Okay. Equals and stack. Just like do this. I think previous, like we use this.
Okay.
This is closed. I have to find the open. Okay. This is this. Find that. I know, like if I'm already here, I know I'm at a closing character because I'm assuming that the string only contains these closing and opening closing characters, and I immediately try to validate if it has a a matching one at the top, because we know like the stack is not going to be empty if we even get here. And if it passes that, then we know it matches the corresponding one, and we can just do stack.pop, and we don't need to do anything about the current character because it's the closing one, and we have already dealt with it. And we can basically just do that, iterate through the string. In the end, we just need to check if stack is empty. Because if it's not, then it means we have some dangling open characters. So that's pretty much like the algorithm. I'm just gonna do a quick test with the conditions that we have.
Yep.
It's gonna yeah. So let's see, where should I write? Okay, empty string. We know this is already handled up front. Say we have this. This is a valid string. This is going to be our stack. Initially, we see open character. We add it, then we move on. We see another open character. We add it, and then we move on to the first closing character. Okay, so we get the previous. So we know that previous is now going to be this open character. The current char is this one, and previous is indeed that. So this condition is not going to work. So this is not going to return false. We pop the stack. So the stack is just going to be the open bracket right now. Then we move on to the next one. We get this character. Okay, it's equal to that. We do stack pop. Okay, and in the end, length of stack is 0. We return true. Now let's try one with the encountering closing char without open char. Okay, this.
Okay.
Yeah. So yeah, same thing. We append the left, and then when we go to the next one, this is gonna skip. We do stack.pop.
Okay.
It'll be empty, and then we get here. We add it to the stack, and then we finish iterating through the string. This is gonna return false because we have the dangling left. And yeah, with the last one, let's do it for the sake of completeness as well.
Okay. Hello?
Yeah, we add the left, and the first open one, we're gonna skip this as well. Stack.pop, seems good. Okay, and then we finally hit the last character, and I think this is where we get the previous, and the previous is currently this. So it's indeed not equal to that, and so we return false over here.
Okay.
Yeah.
Time space complexity?
Sure. So time-wise, we are also doing O of n because we're just iterating through the string once. Worst case scenario for space, we would also be O of n. This case would happen when the entire string is just left open characters. So we just add it all to the stack, but we don't end up using any of that.
Sure.
But that would be, yeah.
Okay.
Yeah.
I think that's fine. Yeah. So that only took you like what, 10 minutes to do? Did it feel like 10 minutes?
Yeah. I don't know. I think like the testing probably took like 4 to 5 minutes. So doing it, I think like maybe 5 or 6. So maybe 10 to 12, I think. Yeah. I didn't check off the time. Yeah.
I think it's perfectly reasonable to do this problem in 10 minutes to be complete as possible.
Yeah.
And so my question to you is like, how do you feel about doing it this way, being with this clean approach?
Yeah, I think it's definitely good. I'm just afraid like sometimes it may just be time consuming, but I think in terms of testing, this is definitely pretty good.
Look, I'm gonna tell you this. Like, testing is pretty important in order to make sure you catch yourself on those ideas. You know, it's like normal software engineering, right? It's like, oh god, I don't want to write tests. I don't want to test my code. I just want to ship to production. Same thing, man. It's like it's not the 90% of the time the code runs that will kill you. It's that 1% of the time when, oh shit, you didn't think about this or didn't care to test for it.
Yeah.
So
makes sense.
It's the exact same thing here. It's the same principle. So and besides, you're hitting sub 10. You're hitting like 10 minutes for this, and so I'm pretty confident that once you get really comfortable with this, you can probably hit medium problems for like 20 minutes or less at some point.
Okay.
So yeah, just keep this up. I think this is a good start. And I think you're pretty satisfied with the approach as well. Yeah.
Actually, do you like writing out these test cases? I think at least with array, I could actually write out concrete examples, but with like tree problems, it's like very hard to like write out. It's just more I would just write out English sentences to say like what I have for a test case.
Yeah. Now we're just doing test case to make sure that we validate what you're doing.
Yeah.
And right now you're being a lot more objective about this as well. It's like, okay, this is what I need to do. This is what I'm missing. This is what I need to cover. So it's a lot.
Yeah.
It's much better than before for sure.
Okay.
In that case, let's switch over to system design interview. What have you done so far from that? And what projects?
Yeah, I mean, so far, like, I haven't been doing much. I've just been reading DDIA and like really ramping up on it. But I plan to do another mock with my coworker. Either I do it this week or early next week. And he said like I can basically just choose from like any of the he basically lets me to choose like if I want to do a product one or a system one. Yeah, so I haven't decided that. I might just do another product one, just because there's only like 4 or 5 product like question bank they could choose from Facebook. But like system like classic ones, they could have like unlimited ones to choose from.
Oh yeah, yeah. I want you to pick the one that you're comfortable with. But since you seem to be picking product design ones from last time, and you seem like you're reading DDIA, but like I said, like DDIA is a completely different beast. And it's good to get if you. It depends on how much of it you're able to absorb. If you could, even if you could absorb all of it, I still wouldn't recommend the normal system design one. But then the product one is also like a bit more nebulous as well, more freeform. So it's like we're fighting an uphill battle here with this, but it's not like the end of the world either. I want you to pick the one that you feel naturally more inclined towards.
Yeah, I definitely. So this is conflicting. I also been reading blog posts or like videos that you told me to.
Yeah.
I actually very much enjoy reading DDIA, and that's why I've just been reading it because I actually enjoy reading about it. But the initially like I just started practicing the product design with my coworker just because like at that point like in terms of knowledge and like practice like I felt like product design would be a little easy for me versus the classic one. That's why I started practicing the product one with it. But like, I actually very much enjoy reading DIA and stuff like that. But like even when it comes to the product design, it's definitely not like the classic system design, but like it's still I still need to know about like the stuff that DDIA talks about because like when he was like testing me, he would still ask questions about like how would storage look like, like how would you cache it, like reputations and stuff like that. So like those I still get tested on those stuff. So it's not like the same, but like I think like the knowledge of like storage and like caching and all that still applies to the product question. It's just that it will be a little more product focused, but it's not like I don't need to know about like the backend system stuff.
Right. It's like if I asked you if you were to do relational joins on a query, what would the tables look like? It's more or less like that.
Yeah.
Okay. So I'm going to give you I'm going to give you a I'll give you a problem then. And I think this will be a very interesting one to see if you can do it. So in this case, we're not going to necessarily focus on the end user as our customers. Instead, a lot of times in programming and at scale, we actually focus on the developers themselves as our consumers. So what I want you to do is I want you to design a CDI CD pipeline. And I want you to design it at scale.
Sorry, were you typing? I can see.
My screen is still shared. I'm at the. Do you see where I'm at?
Oh, okay. I see. Yeah, I see it now.
So I want you to design a CI/CD pipeline for a bunch of people for a repo. So consider that like at Facebook, you have everyone who's like trying to commit to a repo, right?
Yeah.
I actually want you to design this.
Okay. Let's see. What is the scale we're looking like? How many users and like what is the I would say amount of like how do you call it, like submissions into the pipeline in terms of like I would say like either per hour, per minute, or what is the volume we are looking at right now?
Okay. That's a good start. Yes. I would say the volume we're looking at. Let's assume that we're handling about 100 diffs per day.
100 diffs. Okay, 100 diffs per day. Okay, that's not crazy bad.
For landing it. But then you might have a bunch of things in submission for CI as well. So let's say approximately. Let's say 1,000. Let's say 1,000 CI, 100 for the land. Approximately.
Okay. And so here you say for a repo. So are we assuming that we only have this one main pipeline into one main repo? Is that what we're focusing on?
Yeah. Let's say that everyone's committing to the same repository. That these one 100 diffs per day are going towards the exact same, let's say Go repo, or it could be a Python repo. It doesn't matter.
Okay. Okay. Um, and before that, this may be a stupid question, but is this, are you asking as like a more classic system design or like more of a product one?
I want you to drive the
Oh,
conversation. I'm gonna say,
okay.
just as like a hint for me, I want to see like how you evaluate the needs of the consumer, and then create a pipeline structure for that.
Okay. Okay, let me give you a minute. So we have to design a CI/CD. Okay. So users are mainly just going to be developers. Let's see.
Yeah, keep in mind, like I said before, the end user is no longer the general public. The end user is other developers in the company.
Okay. I'm just trying to see like what else. So obviously like this CI/CD pipeline, we need to obviously like accept this, or like yeah. So like, and this is or like whatever else. This goes to like 1K CI and then 100 landing. What else do we want to perform? I'm actually not very like familiar with like how like what are the actual like purposes. Like I've worked with CI/CD before, but like not very in like I would say like not very deeply. So I guess like I'm just trying to struggling up like the actual features and like the things that a CI/CD pipeline would do, if that makes sense.
Okay, let me ask this then. What is your understanding of CI/CD pipeline to begin with? Like, what do you think
Um,
it does? And yeah, and what is it used for? Let me ask you that.
so as far as like I understand, it's a pipeline or like a workflow defined in order to make sure changes are integrated into like one single stream or like one single centralized place.
Sure.
So basically, we have to consider like we have to take in like a lot of different take in input from different sources, and we have to try to integrate them into one single place. So this also potentially means conflicts can happen. We need to resolve them. We also have to care about like I guess like concurrency because like like developers are not gonna commit like one by one. Like you can commit at the same time. So yeah, that's like my understanding of it. But am I missing on like other key features of like a CI/CD pipeline?
I'm saying you're maybe 20%. You're scratching the surface of what CI/CD pipelines for. Let me help you out here.
Yeah.
So a
Okay.
CI/CD pipeline is continuous integration, continuous deployment, right? So
Yeah.
everyone is basically working on a bunch of diffs, right? And they're trying to submit it
Yeah.
to a central pipeline. There's only one
Yeah.
pipe.
Yeah.
In theory, there should only be one pipeline because you don't want potentially conflicting diffs to
Yeah.
to conflict each other. So CI is just basically like, hey, I have this diff, run these tests, make sure it's okay, make sure that my change is actually okay as I have it today, right? And then CD
Yeah.
would just be like, okay, let's actually merge this change in and then cut a build or something like that, right?
Hmm.
Yeah.
Okay.
So you might have yeah, that's part of it. So let's go ahead and work with that definition for now.
Okay. Okay. So this is going to be the definition that we're focused at right now. Um, so let's see. So end users are going to be developers in house. Um, okay. So first thing, like for CI, like we definitely need some kind of a component application to make sure changes are valid.
Okay.
Okay. That's one thing. It's gonna list out some of the key things that we need to support for in both like CI and CD. Be able to handle like high input. So yeah, up to 1,000 per day. And this also means like we can get multiple input at the same time as well. So we may need like uh, if we're gonna have like one single component, this has to be able to take in multiple sources at the same time. Otherwise, we could have like
I will say
multiple
that for
components and
okay,
app.
actually, well, we can talk about it later. But yeah, keep going.
Okay, or we could have like multiple components at different sources to take it in, and have like a main CI component that would then consolidate all of those. So either CI, okay, CD, guess this would need to be able to, let's see, okay. Okay, merge is pretty obvious, but let's see what's another way to put this. We need to be able to line up the changes or diffs one after another to be merged, and we also need to be able to like create cut out a build package for deployment. Let's see. So developers in-house, they only care about submitting the div. So we don't necessarily like, I would say like need a fancy UI for them to like submit something. We can assume, sorry, were you gonna say something?
Assume that the UI is kind of built out for you.
Okay. Okay. Let's see. Okay. Right now I'm just kind of stuck in terms of like direction, and like where I want to go next. So, okay, we have the UI to build out, to take in the input, and we need to have a pipeline. So I'm thinking more like the pipeline would be okay, it needs to be obviously available, because we want to be able to accept changes at any time. So this would mean that we could potentially kind of use a open, like I would say a stream to take in changes. Stream taking changes, and then here we would do validations, like if needed. We kind of queue them for CD. Yeah, and from the CD side, okay. So in the CI, we also need to be able to do that. Let's see. Okay, I'm also trying to look at, okay, conflict management would be something we do at the CI level. Okay, so here we need to handle conflict. So let's see, what are the different kinds of conflicts we can have, because we can accept changes at the same time. We may potentially have two diffs that change the same code. Now we can try to resolve it ourselves if possible.
Okay.
Otherwise, we would. Okay, so typically, like one way to do this is we can say latest diff, right? Latest change will win.
Okay.
But this latest this timestamp is kind of dependent on when it's submitted. So but we don't actually know. Like say like one person could have made the changes earlier than the other person, but he submitted like after.
Let me ask, why would you pick this policy first? Why do you want to give priority to someone who has the latest change? Is
Oh
this
no,
for
no, I'm not
CI?
saying like we're gonna. No, no, I'm not saying we're pursuing it. I'm saying like we can. This is one way we can do this.
Okay.
But I'm not saying that we're pursuing this.
Okay.
I was just because I was saying like we can try to resolve it ourselves, and this is one way we can do it. But I'm like yeah, like and then that's when I brought it up where like the timestamps are not reliable, so we ideally we shouldn't go with this. Um, so I'm just gonna take it back out. So in terms of resolving conflicts, what other options we have? Let's see. Okay, in the typical database setting, we would have logs, but because these are code files, it's not like they have the logs entirely when they're coding the entire time. Let's see. Based on like what I've worked with, we can try to say we have like some kind of application that could do simple simple resolves. So for example, same file, but changes are at different places. We would just aggregate them. Now, if the same function is changed, we need to decide on one of them. Let's see. It's very hard. Yeah, I guess it's very hard for the pipeline to determine like what changes are correct, because this is like in-house and like a lot of things could be going on. Many changes can happen, right? And
Yep.
so, especially during the holidays, so we don't want to let the application determine what is correct or wrong. So I'm kind of more in favor of saying we would reject. Okay, we can reject both because then that would be bad
I mean,
experience.
the question is whether or not you want it to be opinionated or not, right? Do you want the system to resolve it, or do you want to let the developers resolve it themselves?
So I do want the developers to resolve it themselves.
Okay.
But like if if we have like two or like multiple competing changes, and I reject all of them, then it would just be bad developer experience, right?
Yep.
Because then they would obviously like when they get the rejection, they're all gonna retry at the same time. Maybe not all of them, but like at least 2 or 3 will retry at the same time, and then they get that same rejection, and that thing just keeps happening and happening, and it's just like no one's gonna be able to put in changes, right?
That's fair. Yep. That's also something you need to consider.
Yeah.
So I'm going to say
So
this.
I want to be able to.
Go ahead.
Yeah. No, you were going to say something.
So what I was going to say is that, okay, well, you could, like, let someone land and then let someone else suffer the consequences, let them both suffer the consequences of, or, n number of people suffering the consequence of, like, them having competing changes or whatnot. It's ultimately what you want this to do.
Okay. So what I would like this to do is, I'm assuming that, the component that handles like the diffs is already built out, and that the component, I'm just gonna list this out. Right.
You can assume it's like a Git or a Git equivalent.
Yeah, and I'm assuming like the component, like the how do I say it, the diff review or like submission component has automatic tests. Like it could be like end-to-end tests, integration tests, unit tests that will run upon a diff is submitted before they can even try to ship it, if that makes sense.
Sure, yeah, there are automatic tests
that
are run on it as part of CI. Yeah, you can assume that there's like some function here that run test or whatever.
And so based on that, we're actually going to accept the change that is based off the latest revision, or like the most up-to-date revision. So say, like, I'm just going to write out an example here of what I mean by this. So say we have a developer 1. His version of the repo is say 10 a.m. But he submits his changes at 2 p.m. and Dev 2's version of repo is say 10:30, submits his changes at like 1:55. So even though this came in before this, we want to accept this change because it's based off a later version, and so I'm gonna assume like the I'm gonna want to go be in favor of this because the test we ran, even though both are accepted, this is based on a more recent version, and that's why I'm gonna accept the latest one.
Okay, sure, that's fine. So just accept the 155, and then if you Dev one submits at 2 p.m., just tell him, hey, you fucked. As like someone else landed, fuck, you're fucked.
Yeah.
That's
So
fine.
I would so like in this case like person would try to uh ship, and we would obviously start running. We would still allow them to. We would still run the process because we won't be able to know that upfront, right? Because it hasn't come into the pipeline yet. So we still initiate the trigger the process. But once we hit that blocker, we will then terminate like end the process and notify the user that to kind of pull like the latest changes and resolve any conflicts. If that makes sense.
Sure.
So say
That's
like
fine.
and this scenario is only based on like if these two developers or like multiple developers are trying to like put in changes at the same time. Say like if we happen to land the changes before the other developer tries to ship it, then this is not going to happen. But this is only based on like when we have competing changes.
That's fine. Yeah, I understand
Yeah.
like what you're talking about. And that's okay. I do also want to point out a few things.
Yeah.
So you have the conflict resolution. Now, what happens if we have everyone? What happens? So is this is part of CD, right? I want you to be very clear as to what part is part of CI and which part is part of CD.
So I was actually like because I'm not actually very familiar with like how like if merging is typically done in CI/CD, but this when I was explaining this,
Okay.
it's yeah more so on the CD side because I need to be able to line up the changes.
Okay. Okay. So then I guess you can assume that. So let me ask you, for CI side, let me ask, how do you think it works?
We obviously get like yeah, I think that's the thing. I don't know how it works in general. Um, but based on like what I think it looks like it would be everyone submitting to one centralized location,
Okay.
and that location obviously has to be highly available, taking in inputs,
Uh huh.
and it will consist of some metadata for each of those input
Okay.
and run some validations, just like doing a quick smoke check. And then later on, we would pass it to the CD for merging, and CD would then take those inputs. And because we have the metadata, and like for example, we can have like the some of the changes, like the location of the changes.
Okay.
So when they get to the CD, we may have like 2 divs or 3 divs that want to make changes at the same location, and then that's when the CD component would then try to resolve the conflicts if possible. If not, we pick the one that passed the tests based off the latest revision, and then reject the others and notify the end user or the developer in this case.
I mean, that's fair. I guess that's a very fair cursory understanding of things. I'm not gonna fault you for that, I guess.
Mm.
I would say though that, how to describe it? So CI, the bottom. I might as well just tell you how CI actually works. So CI works
Okay.
by basically saying, hey, we're going to spin up a node or a machine, and then we're gonna run some set of instructions in order to essentially run our environment, which is why you frequently see Y is paired with Docker. And then we're gonna run this command like download diff, merge in, run test, and then it's a basic smoke test like you said. But I'm just giving a little bit more detail into it. We actually just spin up a machine. and we can have different machines. The next, because one time you run CI on a machine, next time it could be a completely different machine, right? And the CD would just be like, okay, well, we need to, now that everything is good, let's merge it in, into the main pipeline. And so for that, we have what's it called? We have the diffs, we have the validation, and then we have like tests running, right?
Yeah.
So I want you to, knowing that, I want you to run with that ball and say what are the possible things that can go wrong and how you intend to handle them.
Okay. So machines spinning up. That's one thing you mentioned. I'm just gonna write out the key points that we have. Machines running up. What else? Running a command program is tests. Those like the things you mentioned, right? I was trying to like take notes, but I was also just trying to listen in. So some of the possible failures are obviously like when we run these machine and nodes, they could fail or like not be able to start up due to some hardware failure. That's pretty common. Running command program, I'm not gonna say hardware failure because we already covered that up here. But obviously we can have some say network failure. For example, we want like a machine to run a certain command, but then because of some network issues, that command never got to the machine. Or if we wanted to run the same command on 10 machines, but only got to 2 of them.
Sure.
And the other 8 didn't receive it. And then obviously we could also have like software bug because these CI pipelines are also written by developers. So they themselves may have like software bugs that cause issues.
If the diff, okay, sure, go ahead, keep going.
Yeah, and then like the next thing is like the pipeline needs to run its own validations. Now obviously like we could also still have like some transient errors. I've seen like very transient errors where like because a lot of the things are stored in like also databases. I'm assuming like when we want to run certain things, we may need to access the database for validation or whatever reason, and that could fail as well.
Sure. If you have like basically
error,
you're talking about flaky tests essentially.
So flaky test is one. Yeah, flaky test, correct. Flaky test is that, and then let's see. Tests themselves. The tests themselves are not. I would say do not cover everything. So these are the main failure points that I'm kind of looking at right now. So let's talk about like how I would kind of like think about accommodating each of these. So in terms of like machine or like nodes failing to spin up, we can always have like backups to accommodate this. Say if we want to run, say if we only need 5 machines, we may reserve we may reserve like 2 or 3 more of them, and this number would base on half of what we intend to use, and if for these actually wait, I guess like in a big company, like we will have the capability to kind of automatically reserve a new machine or new node in case of one fails.
Sure.
So yeah, I guess we wouldn't need to reserve in advance because that would also just be a waste of like reserving resources that we don't intend to use. So we don't need to reserve in advance. We can reserve a new instance the moment something fails. But because of this, we always do not want to run something on only one machine. So even if like 1 or 2 fails, say if we always run it with a minimum number of like 5, then we can at least make sure that if 1 or 2 fails, we still have like some machines running to be able to like to be available to take an input or like run the thing. Obviously, we can't guarantee everything, right? Because like if a blackout happens, then everything is just going to be down. But at least in this case, like we can kind of handle and tolerate some kind of failure. Although those machines would just have to be dealing with high load.
Okay,
but once we set up
like
the
you said,
reserve,
you're not assuming. Hold up. So you're like you said, you're assuming that not all these diffs are gonna run on one machine. Yeah, you're gonna have a bunch of different nodes or a bunch of different machines. So I want you to shy away from like all these giga high technicals. I really want you to focus more on like what how developers are going to use the machine and what can go wrong. Because I feel like you're kind of diving a little too deep into it. Now, that's not necessarily wrong, but it's like I want you to really focus on the things that matter.
Okay, so you say that last part where you mentioned you want me to focus on how the developers are gonna use the
Yes.
machine.
So let's say, for instance, we use your system, right? I want you to first
Mm,
walk through it. Like, you do it end to end, right? I think you briefly talked about it. They submit to
yeah,
CI. We reject if there is any like things that don't pass, and then if it passes, then we submit to CD, right? And then you talked about like
yeah,
conflict resolution, saying, okay, well, we are going to land based on this. Now, my question is, well, for CI, when we do the initial tests, are we going to test it against the latest branch, or are we going to test it against all the changes as they have done it? So, you know, like someone might be on an old branch or an old diff.
yeah.
How are we going to do this?
Okay,
Ask it.
so this is like you see where my cursor is, right? So I'm
Yes,
just
I
gonna
see it.
start typing. So we have a user. Obviously, user is gonna pull some kind of revision, right?
Uh-huh.
And they're gonna make local changes to whatever development they need to,
Right?
and they're gonna submit it for review. And this is where it's first presented to the application, or like like the application we talked about where the some of the initial smoke tests will be ran.
Yes.
And now upon this initial submission, what I would like to do is that we would also check like we have the ability to check the revision, right, based on the
Yep.
hash they have.
Mhm.
So if it's anything like if it's older than a week, we simply tell them like this is too old, and please rebase. And we wouldn't even bother to run any tests.
Sure.
So that covers it. Now if it's like if it's current enough, we would then run some integration tests, smoke tests of those changes against the latest stable
Okay. Let me
branch
ask you
we have.
then. These tests, are they a subset of all the tests, or are you running every single test?
Oh no, I'm not gonna be running all tests because this is gonna be subset of tests depending on like what changes the user might be making. For
Okay.
example, when they submit it, we know like the different files they change, and from there we could kind of deduct like the different file paths and stuff like that. And I guess like we can assume that we have like the application has the ability to determine like what tests we need to run. If the changes affect like a lot of different places, for example, code mods, then we may want to run like hundreds of tests, right? But if they're making like a change at one very specific file or like one specific component, then we only need to like run maybe a couple of tests. But we would still need like we would still run like integration tests based on like so we definitely have like some set of tests that we will run for sure, and then we have another subset of tests that we run
So
depending
you're
on like
assuming
the
our
location of their
application,
changes.
you're assuming our application will be able to determine the tests that are immediately relevant, including the downstream dependencies.
Yeah, it would do it to its best ability to kind of deduct that. But obviously, like they will always be cases where developers submit changes that do not get caught. And for example, like there are also cases where certain tests, end-to-end tests, especially, end up running for too long, and then our application ends up deciding not to run those when they exceed a certain amount of time, and then we find out that that particular diff caused an issue,
Okay.
and someone needs to fix it.
Okay, so I assume that basically covers your initial smoke test. Now, like you said, if we run the full
Yeah.
test suite, we might choke some machines because we're running like really, really long time, right?
Yeah.
Now, what about for CD? How are you going to enforce that? Because now instead of having multiple nodes that can test independently, now you're forcing everyone through one node. So my question to you is, what are you doing for this?
Wait, I'm kind of confused. What you so I was saying they would submit it to the application, but at this point they haven't clicked the ship it button yet.
Okay.
So up to this point, it's still like in the review application and hasn't submitted yet.
Yes.
And so obviously like these all pass, and then the user will click submit. or say ship it.
Okay.
And this is where we will have like multiple nodes to obviously collect all these changes whatsoever, and then we'll have a main node
Mm-hmm.
that will then take in these changes. So before I mention that, these multiple nodes, they are going to do a couple of things. They would obviously still run like uh, potentially like they could potentially add like some metadata based on changes,
Okay.
metadata for each diff based on those changes. Like although like the main node can access each diff's content, we may not want the main node to do that much computation or processing.
Mm-hmm.
So we could, for the sake of like using up more space, we can duplicate or like end up kind of presenting like a summary for each diff. For example, metadata would contain like timestamps or like location, amount of changes, stuff like that. And then eventually it will come to a main node. And I imagine like the main node would be a machine with a like higher capacity, stuff like that. So the hardware specs will be better than like the smaller nodes, just because it has to handle all of that. And at this point, this main node would then try to assign these diffs or changes to the I guess we wouldn't say assign. I would just say we would then queue these into the CD component.
Okay.
And then when we get to the
So I'm asking my question I'm asking you is how do you intend to validate all these changes? Because it's like if you have a node on CI1, right, and then node on CI2, and then these changes conflict with each other when they go to submit. How do you guarantee you don't land breaking changes?
So that's where the CD component then does the whole conflict stuff.
Okay, so you're gonna say, hey, there's a conflict here. All right.
Yeah.
What if it's not a merge conflict? What if it's downstream dependency?
So as in like, okay, they don't. It's not necessarily a conflict, but then somewhere downstream something breaks.
Yeah.
Is
So
that what you
let's
mean?
say I have a module. I have this relationship, right? Module A,
Yeah.
module C, module B, right? So
Yeah.
let's suppose that someone makes a change in module A, right? And then and then it changes the behavior of C, right? Because C is relying on it, right?
Yeah.
And then let's say someone makes a change in module B, right? And then it changes the behavior of C, which then breaks. Let's say it's breaking.
Yeah.
So then.
So yeah, and this I guess this kind of ties back to like the developers as well. So it's like I imagine like if they're making changes to module A and module B, these two modules would already have existing tests to kind of validate that. And so I guess like when it comes into the CD component, it would include like we would be able to like kind of see like that conflict reflected on the test. And in the case that these conflicts do not appear, then we would simply I would say like pick the one with the latest revision
I mean,
that we
okay,
tested.
you're picking it, but then you just reject the other one, right?
Yeah.
Okay. Okay. So we're running out of time here, but notice I wanted to give you some feedback on what you've done. I feel like you just dive too much into the raw components without illustrating the user story, and this is like something that's very important for product, and I think we touched briefly on it before. So what I want you to do is really think about the user story. How does the user use your product? This is the current state of the world, right? Like, and I just say that with the product standpoint, it doesn't matter. You really need to think about like how the user is going to be using it, and then like what are the different ways they can use it. How do each of these stories conflict? And what I noticed when you were doing it is like you're just talking about like the whole actual thing. You're talking about like, oh well, this is how the diffs are going to work. It's like great, but then how are the people going to use your freaking this user freaking system, right? And that's when I really started like, okay, well, I had to clear up the understanding of like, here's what CI/CD is. And then I had to really get you to explain it. But to me, like your explanations were like kind of murky. It wasn't immediately clear what your assumptions were and what they weren't. You did it okay here at the beginning, like designing like, oh, what's our volume? But you need to do the exact same thing here with the users. So
Yeah.
one of the things is like, okay, how long are these tests gonna run? What component is responsible for what piece? Is responsible for what? You know, it's not unlike the what's it called, the Facebook string changes that you were talking about. It's like, okay, well, we have a certain database that is responsible for holding our string translations. And then we have this component here that's responsible for XYZ, you know? And so here, to me, it's like, okay, I get that, you know, you're going to have a component that's responsible for changing behavior of C and, you know, running tests. But then to me, it's like, it wasn't clear whether or not you're going to run the entire suite of tests, the entire difference of, like, what tests you're running, and then more importantly, what if these tests bottleneck the main pipeline?
Yeah. I definitely struggle mainly because I don't even have like a good understanding of like how CI/CD works to begin with. Obviously, I don't have like a clear enough idea of like how it works. So, and yeah, in terms of direction, I think I definitely got lost and like went to the wrong direction. And not focused enough on.
I don't think it's so much the CI/CD, your misunderstanding of it. I think it's that you didn't paint a story of like how this project is even being used. It's the same problem as last week. It's like, well, how's the product being used, and then how does a change, which is like internationalization or whatever, change how the product will be used, or and then which leads to like the internal guts changing. It's the exact same questions that we're asking ourselves.
Yeah, but I feel like with like the other questions, like for example Tinder and Facebook, I at least kind of know like what it is currently like. And because I've used them like directly before, but with like CI/CD, like I've not used it to that extent.
But I think all you need to know about CI/CD is that you're submitting diffs to a bunch of different machines. Machines are going to validate it for you, and then you merge it onto the main pipeline in order to merge it into the code base. I think that's a pretty good summary of like what your knowledge was, right?
Yeah.
That's fine. You can run with that.
Okay.
Like notice here, like when you were talking about like, hardware failures, network failures, tests, I didn't need you to do all that. Like all I'm asking is like, hey, what if one of these diffs changes with another diff, right? What do they block each other? And you kind of already talked about it. You had this I think you already naturally understand it here. But it's like when you started getting into the hardware portions of it and how these are provisioned, then that's where things got kind of fucked up. But to me, this is like the main story.
Okay.
Like this is the product side of things.
I started talking about this because you kind of gave me like a brief summary of like how it works, right? And then you told me to didn't you tell me to like mention like what are the possible points of failures?
Yes, I did. Possible points of failures, and there's many different ways to fail, not just in hardware, but in the users themselves. Like again, what if every single user decides to submit to CD at the same time? That's a possible failure, isn't it? If you choke the entire pipeline.
Yeah.
What if a bunch of users fail tests? That's another one. And what if we want to, update these, the flow of the pipelines themselves? Well, do we have a mechanism for that? Do we have a way of like, what if, we have a Facebook outage and we need to bypass all the tests? Do we have a break glass button? So this is what I'm talking about. Like, notice here that in all these situations, I didn't talk about the hardware at all. I talked about all the possible ways this product can be used.
Okay.
So you get my point here, right? You're focusing on the wrong thing.
Yeah. I pretty much like I definitely focus on the wrong things.
Okay. And so I really want you to get in this habit of thinking of the user story. Think about how the user uses your product. Because that's going to really help you, not just in like, say this, it's going to help you in any single product interview. So let's actually scroll down. So Facebook, internationalization, let's do the exercise. Let's say we just launched Facebook and then we want to expand from colleges outwards, right? Well, what's our user story? How are users going to be using this? And does that user story change whether or not we're in China, we're in Hong Kong, we're in Russia, whether in Germany? Well, the user is going to see ads. The user is going to see content. And the user is going to see like geographic locations and receive a bunch of messages, right? And then we also have like the user is going to see a bunch of privacy related issues as well. Like you're going to see Facebook messages from 7 years ago. Now, do we want those Facebook messages from 7 years ago to be available, or do we want them to be, deleted because of privacy reasons? We want to change the
Yep.
ads that are shown because the user might expect a user in Germany doesn't want to see an ad in Chinese if it's like, if they think it's in China, And it's
Yeah.
the same exact story. It's how are these users using the product?
Okay.
And I think that's the fundamental thing.
Yeah.
I think that's one of the core things that you don't do. There's many components to this, but I think this is like if you can start asking yourself this, like in any blog you read, any product you think about, and then just try to this exercise, I think it'll do you a lot of good.
Okay. Okay.
Yeah.
Yeah. Yeah. I definitely did not spend much. Yeah, I did totally miss on the user stuff.
Because fundamentally, who's using your product? Other people or other machines, maybe. Like if you're writing things for other machines to use, but fundamentally, you need to think about the user. That's true in any product.
Got it.
Yeah. So we got like I'd say we're almost out of time. Let me go ahead and look at your schedule. I want you to like do a little bit of light practice on the system design, but I want you to try keeping this question in mind and make it a habit. I want you to focus more on the leak code stuff that we've been talking about and this whole idea of testing. I know we went over a lot today, but I want you to focus primarily on the testing, the recursion, the array, and I want you to focus on these things.
Okay.
You can't just go back over past problems and that you weren't able to solve, and focus in on that.
Okay, sure. As for like lightweight system design practice, should I just like kind of like search online for like sample questions to practice on and do that?
Yeah, if you want to, but I would really like you to focus on EPI for now. The weekend, I would say like Thursday onward, after the replay analysis, if you feel very good about EPI and you've cleared most of the issues, you can do some system design. But I still think that if we're targeting 1127, I want you to focus on EPI because I still want you to try applying this to dynamic programming next week.
Okay.
Because there's a lot more chapters in here. I think we can do like a searching as well.
Yeah, sure.
Yeah. So that's it from me. Anything from you?
No, I'm good.
Okay, sounds good. Then I'll let you go.
All right, thanks, man. Appreciate it.
All right, sounds good. See you Thursday.
All right. Have a good one. Bye.
You too. Bye bye. All right. I guess that's it from me. Seems like the stream has died down for the audience. So you know what? Thank you all for watching. I'm going to close out the stream now. I will not be streaming tomorrow. One of my clients did drop. And so we will hopefully have a stream on Thursday. If not, then I will go ahead and upload a video of me doing the replay analysis. But until then, good night, y'all, and thank you all for joining me.